Now, example 4, we need to find the least common denominator of 8 and 6, which we know to be 24. So it'll be 5/8 times 3 over 3 minus 5/6 times 4 over 4. 5 times 3 is 15. 8 times 3 is 24. Minus 5 times 4 is 20 over 6 times 4, which is 24. 15 minus 20 is a -5, and we carry over our 24. So that is our final answer. Now, we have an alternative method for finding the LCD, or least common denominator. We could use the prime factorization method. Now, this method is good that we used earlier for the previous problems. However, if you do not know how to find the common denominator, you could run into a lot of problems. Now, this method, although it may be a little long, is still very effective. Okay, now, we're asked here to find the LCD of 18 and 28. So first we're going to find the prime factorization. Now 18 we know gives us 2 times 9. 2 is prime. And we know 9 breaks down to 3 and 3. So the prime factorization of 18 is 2 times 3 times 9. Now we go to 28. We add 2 times 14. 14 breaks down to 2 times 7. Now, our prime factorization of 28 is 2 times 2 times 7. Now, our prime factorization of 18, we know is 2 times 2 times 3. It's 2 times 3 times 3. Okay, now, the prime factorization of 18, as we see here, was 2 times 2 times 3. So, we will put that here, 2 times 3 times 3. Now the prime factorization of 28 was 2 times 2 times 7. Now, we want to build our LCD. Now this is how we would build the LCD. We would look at which factors they have in common. Like here, they have one set of 2's in common. So we will write that once. Okay, now they have nothing else in common, so you will write what's left in numerical order. You have another 2 that's left, you have 2 3's, and you have a 7. Now remember, whenever they match up, you only count it once, and then everything else that doesn't match up with anything else, you write down. So, now we build our LCD. Now we multiply. You have 2 times 2 is 4, times 3 is 12, times 3 is 36, times 7. Now we can go off to the side and take 36 times 7. 7 times 6 is 42, carry a 4. 7 times 3 is 21, plus 4 is 25. So, the LCD is 252. Now we want to find another LCD. We use 45 and also 50. So we take the prime factorization of 45, which is 5 times 9, and then 9 breaks down to 3 times 3. So now our prime factorization is 2 3's and a 5. And our prime factorization of 50, we have 5 times 10, and 10 breaks down to 2 times 5. So we have a 2 and 2 5's. So now this is what we do. We always start with the smaller number. We had nothing match up with 2, so we'll write down 2. We have nothing that matches up with 3. Now we're talking about match up means from one number to the other. So we'll bring down our 2 3's. We do have one set of 5's that match up, so we'll write that once, and then we'll bring down the other 5. Now, this is our LCD. Now we multiply this out. Now we add 2 times 3 is 6, times 3 is 18, times 5 is 90, times 5 is 450. So your LCD here is 450. Now we come here to this larger number. We have 168 and we add 210. Now we could break 168 down to 2 times 84. 2 is prime. We could break 84 down to 2 times 42. 2 is prime. We could break 42 down 2, we could do 7 times 6. And 6 breaks down to 2 times 3. So with 168, we had 3 2s, a 3 and a 7. Now we go to 210. We could do 2 times 105. We could do here 5 times 21. And 21 breaks down to 3 times 7. So now we have a 2, a 3, a 5, and a 7. Now we want to build our LCD. Now remember, this was the prime factorization here. Now we do our LCD. We only have 1 2 here, so we'll write that down. 1 2 that matches up, so we bring down the other 2 2s. Now we have 1 3 that matches up, which happens to be the only 3s here. We have nothing to match up with the 5, but we also have these 7s that match up. So we bring that down. Now, our LCD after we multiply, we have 2 times 2 is 4, times 2 is 8, times 3 is 24, times 5 is 120, times 7, which is 840. So our least common denominator here would be 840. Now we scroll down. Now what I like about this next page is our denominators is also what we found up here when we found our LCD. Let's just scroll back for a hot minute here. And if you notice here, we have 45 and 50 for our LCD. And we know that gave us 450. And now we have these fractions here that have the denominators of 45 and 50. So now, we already know that our common denominator is 450 because we did that in the previous problem. So we would do 450 and 450. Now, when we're using the prime factorization method, this is what we could do to find out what we will multiply our numerator by. What we would do is this here. We would say 450 divided by 50. 450 divided by 50, we know is 9. And you could go off to the side if you want to. You could say 50 goes into 450. That'll be 9 times with no remainder. So what would end up happening here is we will multiply this numerator and denominator by 9. 9 times 9 is 81. Now we go here. We would take 450 divided by 45, the new denominator divided by the old denominator. So we would take 45 into 450. 45 goes into 45 once. We have 0 left over, so we know that that's 10. So that means we will multiply this numerator and denominator by 10. 8 times 10 is 80. Now we add them together. 81 plus 80 is 161 all over 450. And that is the final answer here. Now we go here, 168 over 210. Now we found the LCD from the previous problem. The LCD was 840. Now, what we have to do is here, we'll take 840 divided by 168. Now listen, this isn't as smooth as it was here. So this is what we need to do is this here. There's another method we could use. Remember, we found a prime factorization of 168. Now the prime factorization of 168 was 3 2s, a 3, and a 7. So what we need to do to find out what we need to multiply by the 168 is to take out all of the numbers that we have for 168. We had 3 2s, which we need to get rid of. And we also had a 3 and a 7. So what number is left? You're right, 5. So 5 is what we need to multiply our numerator and denominator by. So let me go ahead and write this here. So with the 168, we'll multiply the numerator and denominator by 5. So 5 times 168 is 840. 5 times 25 is 125. Now we go back up here. We look here at the 210. Now with 210, we had these numbers here. We had 2, 3, 5, and 7. So we go back down here to the LCD. This time I'm going to cross them out. Okay, so we'll cross out the 2, we'll cross out the 3, we'll cross out the 5, and we'll cross out the 7. Now the numbers we have left is 2 and 2. 2 times 2 is 4. So now we will multiply our numerator and denominator by 4. So we will multiply this numerator by 4 and this denominator by 4. 210 times 4 is 840. 37 times 4, you know, that gives us 28. This would be 148. So now we have 125 minus 148, which would give us a negative 23 over 840. And they have nothing in common. So our final answer is a negative 23 over 840. Now we come to section E. We're going to compare the fractions. Now I'm going to show you a very easy way of comparing fractions. There's a very easy way to do this without finding the common denominators, but you must follow this procedure exactly as I tell you. You must take the numerator of the first fraction, or top of the first fraction, times the bottom of the second fraction. So we will have 5 times 3. Then we'll take the bottom of the first fraction, or denominator of the first fraction, times the numerator of the second fraction, which is 8 times 2. 5 times 3 is 15. 8 times 2 is 16. Now we know 16 is greater than 15. So our answer here would be less than. 5/8 is less than 2/3. Now, what I'm going to do here, I'm not going to do this in every problem, but I'm going to show you that this works by first finding these least common denominators. The least common denominator of 8 and 3 is 24. Okay, now we know that 8 times 3 is 24, so we'll multiply the numerator and denominator by 3. So that would give us 15 over 24. And then here we will have to multiply the numerator and denominator by 8. So 8 times 3 is 24, 2 times 8 is 16. And we know 16 over 24 is greater than 15 over 24. So as you all can see that this method works. So let's do this here. We have 2 times 12. Then we have 3 times 7. 2 times 12 is 24, and 3 times 7 is 21. So this is greater than. So we will put that here. Now we scroll down here and do the same thing. 7 times 6, and then 10 times 5. 7 times 6 is 42. 10 times 5 is 50. We know 50 is greater than 42. So 5 6 is greater than 7 tenths. Now we do the same for number 4. 5 times 16, and then 12 times 7. 5 times 16 is 80. 12 times 7 is 84. And we know 84 is greater than 80, so 7/16 is greater than 5/12. Now we come to section F, applications. Find the perimeter of the rectangle. We know the perimeter of a rectangle is 2 lengths plus 2 widths. So we would take we would have perimeter is equal to 2 times the length is 5/6 feet plus 2 times the width, which is 3/8 feet. Now remember, in our multiplication, we would have 2 over 1 times 5 over 6, which would give us 10 over 6, plus 2 over 1 times 3 over 8, which would give us 6 over 8. Now, for some reason this is jumping, but you can rewind back to see these numbers properly. So we will have the perimeter is equal to 10 over 8. We know we can simplify this. This is 2 times 5 over 2 times 3 plus 2 times 3 over 2 times 4. These two simplify out, and that'll give you 5/3, plus these two simplify out, and that will give you 3/4. Now we need to find our common denominator.